Welcome to BrainsMatter, the podcast on science, curiosities, and general knowledge. I'm your host, just an ordinary guy. Hello everyone, and welcome to another episode of BrainsMatter. On today's show, Luke Steller is back. He's an astrobiologist from the University of New South Wales. So welcome back to the show, Luke.
Thank you so much. It's so great to be back.
Life on Venus. So what's all that about?
Yeah, no, definitely. So in mid-September in Nature Astronomy, this amazing article came out where they detected a gas called phosphine on Venus. You might have seen a lot of crazy different articles going around about life on Venus and all these kind of things, which may have, extrapolated a point. But the key findings is very exciting. So basically, astronomers do this thing where they can look at the spectra of different gases in the atmosphere of different planets. So pretty much as the light from the sun comes to Earth and hits us, if it interacts with any molecules along the way, it will actually change the different wavelengths that we receive. And very clever astronomers that are amazing at maths and recreating these different molecules and what they look like can actually tell us, wow, there's a little bit of a vibration. There's a molecule that the light's interacting with in this specific wavelength. Therefore, it must be this molecule. So basically what they did was that they were looking at Venus and they were looking at the sunlight coming through Venus's atmosphere. So not even hitting the planet, but skimming just through, the clouds and the atmosphere around it, getting it onto Earth, getting the wavelengths of that light from the different telescopes that they have around the world. And they found a gas called phosphine. So phosphine is very exciting. It's pH-free, so it's a reduced form of phosphorus. And it's a gas that is very, very rare on Earth. We have around a few parts per trillion. So that's one little piece of phosphine molecule in a trillion other molecules in our atmosphere. So there's very, very small amounts of it. The exciting thing is that the only thing that makes phosphine on Earth is actually a living process by bacteria. There are a few industrial processes that also release phosphine as well. But the main thing is bacteria living in really oxygen-poor, phosphorus-rich environments that produce this phosphine gas in parts per trillion. But on Venus, they're finding this gas in parts per billion, so around 20 parts per billion, which is a lot more than they're finding on Earth. So they're like, what could it be from? So the scientists that wrote that, which was Jane Greaves and a whole bunch of other amazing astronomers, they were being very good scientists. They didn't jump to any conclusions, and they started to try and figure out of different ways that phosphine could be produced on Venus.
Given that Venus is a very different atmosphere to us and it's got crushing pressures, extreme heat, is it possible to make phosphine under those conditions?
Phosphine is produced in our solar system on massive gas giants like Jupiter. It has 20 parts per million. So that's, what is that? 6 orders of magnitude more than what we have here on Earth. And that's produced by these intense heats and pressures pushing it all into there, because Jupiter is such a huge planet, they can actually create the right conditions to make massive amounts of phosphine. However, on Venus, it's a planet, more around our sides of Earth compared to these huge gas giants like Jupiter. So they're really trying to understand why phosphine is there. So the scientists didn't jump to any conclusions. Jane Greaves and the other scientists who wrote that paper, who made that discovery, they were very good scientists. They stood by their guns. They didn't want to jump to any conclusions, and they were trying to figure out what else could form phosphine on Venus. So they looked at meteorites bringing it in and burning up in the atmosphere and depositing it there. They looked at lightning and whether that could stimulate phosphorus to form phosphine at the amounts that they're finding. They looked at all the different kinds of volcanoes that they can model on Venus and see if that could produce the amount of phosphine that they're seeing. And pretty much what their paper did, where they went through all these different options, they did all this mathematics modeling it, and basically they said none of the reasons that we know of on Venus are possible for producing the amount of phosphine that we're detecting. So they were very, conservative. They were very clever. What they said, they didn't say we found life. They didn't say anything like that. All they said, they found unexplained chemistry happening on Venus, which isn't a robust evidence of life, but they can't exclude life being a possibility for that being formed. So pretty much just saying we haven't found life, but we found this gas that is produced by a few different potential origins, and life may be one of them. Because all the other ones we can think of so far doesn't explain the amount of phosphine that we're seeing.
So I've read that Venus has an oxidizing atmosphere. So
Mm.
for people who don't understand chemical processes, what is an oxidizing atmosphere and what would that do to phosphine if it was sitting there?
Yeah, definitely. I remember when I first heard of that as well, I didn't really understand the chemistry, and I thought, wow, oxidizing atmosphere, there must be oxygen there, and it must be some kind of photosynthesis making that oxygen. It's not the case. Really, it's this chemical process called oxidization and reduction, and it's basically the way electrons move between different molecules. And all it really means is that if you have a reduced gas like phosphine in an oxidizing environment, it gets broken up and it gets, oxidized, it gets destroyed by all these other molecules that are present that want to break it down. So the really important thing that means for our detection of phosphine is that phosphine has to be made fresh. If it was
Mhm.
made a long, long time ago when there may have been life on Venus living there millions of years ago, if it was made then, the oxidizing atmosphere would have destroyed it all and there'd be nothing less for us to see today. So really, the fact that we're seeing phosphine, which is this gas that falls apart so easily, there must be something producing it all the time. So if there is life there or a fancy kind of volcano that we're not aware of, it must be still there present to produce the phosphine that we're seeing.
So what are some of the candidates for this sort of thing?
For producing the phosphine,
Yeah.
as a astrobiologist, as someone who studies the potential for life on other planets, I had to be very controlled and not get too excited about this finding because it's still very early days. And the only way we can really tell if there's life there is to send a spaceship there, collect some samples, and analyze it and say, yes, this is life, which would be incredibly exciting. From what I've read and what I've talked to different astronomers and different scientists, volcanoes seem to be a very interesting possibility.
Mhm.
There's all these amazing pressurized systems that we may see on Venus that could produce phosphine in a way that we just aren't aware of, that just isn't here on Earth and is totally outside the models that we can predict. So maybe volcanic. People also look at lightning in these gas clouds that are around Venus that are actually nearly pure sulfuric acid. They're incredibly acidic. And maybe lightning in these really acidic conditions with UV radiation coming in could stimulate phosphine to form as well. So people are definitely looking at different ways. And one possibility is life, which is very exciting. So
Mhm.
if you want to go down that road to, could there be life? The question really is, how did that life get there?
Venus isn't a planet that you would notionally think about having life because of the extreme temperatures, extreme pressures. But as we spoke about when you appeared on the show last, sometimes life can appear in the most extraordinary places, can't it?
No, definitely, yeah. And as we talked about last time, you see life growing in these totally dark, deep sea vents. You see life growing in bubbling hot springs. You see spores of bacteria and other organisms floating high up into our atmosphere and surviving. And they even see life growing on the outside of spaceships in space. Once life's evolved, it's very good at living in incredibly extreme environments. The real question is then, but how does life form? Because as we talked about last time, there's a real difference between a planet being habitable, a planet being able to support life once it's there, and actually life being able to form there from just a whole bunch of organics or molecules coming together in such a right way.
With Venus, is that a planet where the conditions are such where you believe that there is the possibility of life being able to form there?
Yeah, so that's a really good question, OG. So just a bit about Venus, as you said, it's incredibly hot. It's around like over 400 degrees Celsius. So that's, way above the boiling point of water. You can melt lead on the surface of Venus. It's incredibly hot. As you go up higher, into the nice clouds of Venus, it's a lot cooler. It could be a nice 30 degrees. It could be within the Goldilocks zone where life could be present. But even that, in these conditions, is incredibly hard to picture life forming because there's almost no water. It's incredibly dry up there, and there's a whole bunch of pure concentrated sulfuric acid. So it's these incredibly dry clouds made of gases of sulfuric acid, which would be incredibly inhospitable to any kind of chemistry that we can think about. So, when people talk about if life is present on Venus, maybe you can get some incredibly robust little microorganisms living in those clouds, where it's not too hot and they've adapted to those acidic conditions. But could life form there? That's a really interesting question. There's a few different ways that life could have done it. The first one is that life may have formed on Venus a long time ago before it got, as crazy as it was today. So,
because they talk about Venus having the runaway greenhouse effect, don't they?
Totally, yeah. So, what they really thought that, hundreds of millions to billions of years ago, Venus would have been a lot nicer, calmer environment. There may have even been lakes and there might have been rivers on Venus's surface. It wouldn't have been so hot. It wouldn't have been so acidic. It would have actually been a really good place to form life. However, there was all this carbon dioxide and all these gases and water vapor in the atmosphere, and it started getting more and more hot, and all those gases kept all the heat in and evaporated more water off the surface, and it kept exactly as you said, it was a runaway greenhouse effect until you have these dense blankets of atmosphere around Venus holding in all this heat, and you have 400 degrees on the surface of the planet. So it's incredibly hot. So maybe life did evolve when Venus was a lot more calm, a lot more cooler, and it migrated up into these clouds. And it's almost like these clouds are the last stronghold for life, where all life on the surface has died. But up in the clouds, it can survive in these lukewarm conditions that are still incredibly acidic, but maybe can survive up there because it was able to evolve and adapt in a much nicer environment. The second way that life could have got to Venus may have been from delivery from another planet. So we actually know that planets swap rocks all the time. There's some really famous meteorites that we have here on Earth that we know quite confidently, looking at the chemistry of them, that they've come from Mars, There's also instances where we've had impacts of, like the impact that killed the dinosaurs and all these other impacts where asteroids hit the Earth, splattered off a whole bunch of rocks, and they get spread out into the solar system, probably landing on planets like Mars and Venus. So when you think about that, you have these rocks going everywhere, and we know how sturdy microorganisms are, and they cover nearly every grain of dirt and rock that we have on Earth. It wouldn't be hard to imagine life being transported from Earth or from Mars to Venus, landing in the clouds and adapting some way to live there, So maybe life didn't form on Venus, maybe life formed somewhere else, and it just so happened to get blown off and deposited there and could establish itself while it had already formed on another planet.
One remote possibility is that it may be Earthling bacteria from when the dinosaurs went extinct or something like that.
Yeah, no, definitely. And it's very interesting to think about our own origins as well. Are we actually aliens? Did life form originally on Venus long ago when it was nice and cool, or on Mars, and then came to Earth and seeded us here? That's the concept called panspermia, and it's very interesting to think about when you try and understand how we all got here as well.
So speaking of possibility of finding organic chemicals and life around the place, Asteroid Bennu.
Yeah, which is very exciting. In mid-October, NASA landed a small little spacecraft on an asteroid that's floating between us and Mars. It was around 500 meters in diameter and was spinning quite slowly, so it wasn't too hard for them to sort of line themselves up and bounce on it. The thing that I found really fascinating about Bennu and the landing there with the Osirus Rex spacecraft was that even though it took them 2 years to get from Earth to this asteroid, and they spent so much time floating around and trying to get just the right angle and take all these photos and understand what's going on, they only touched the surface for around 16 seconds. It was an incredibly little fist bump, it's an incredibly short little touch. And what they did is that it was almost like a pogo stick where it landed on there, and it had pretty much like a vacuum cleaner and these little jets of nitrogen that kind of like stirred up all the dust and sucked it into a container, and then it bounced off again, this really quick little bump. And from that, they can see how much material they've got, and if they've got enough, which is, at least 60 grams, which is nothing, they'll turn around and bring that back to Earth. The reason why that's so exciting for people like myself who study the origin of life on Earth and looking for life on other planets is that asteroids like Bennu, which to be called Carbonaceous chondrite asteroids, they actually have a whole bunch of organic material on them. There was a really famous one that fell in a place called Murchison, which is in rural Victoria in the 60s.
So if people Google the Murchison meteorite, you'll hear all about it. It's quite well known in scientific circles in Australia.
Yeah, yeah, definitely. And it's known around the world. It's kind of like the gold standard for a clean, fresh sample of a meteorite because it fell on a town and it was scattered, over a couple of 100 meters to a kilometer or so across this town. People heard it land, they saw the flash of light in the sky, and they could actually go out quite quickly into their paddocks and pick them up before there was too much contamination from the surrounding environment. So they think it may have been a pretty good understanding of what organics are found on there. And if you smell this, they said the entire town or where these little bits landed, it smelled like kerosene. It smelled like this sweet organic material because of all of the carbon compounds that were on it. And I was actually very lucky. One of my good friends and mentors, a guy called Bruce Damer, who's also an astrobiologist at the University of California, he has a little jar and there's a tiny sand grain of this meteorite that's in it. And it was put in there, 20, 30 years ago, really early on. And it's still releasing all of these volatile carbon gases. And when you open it up and have a smell, you can still smell this sweet smell of this carbon that formed millions or billions of years ago while it was floating through space. So even though we have these amazing meteorites out there, like Murchison meteorite, the difficult thing is that as it falls through our atmosphere, there's all that oxygen, it starts burning it up, and when it lands here, even if it's on the ground for a few minutes, already biological material can start to contaminate that. So by doing something like they're doing at Bennu, they can collect samples of these organic materials and these rocks that formed deep out in space with no Earth contamination. There's no chance of oxygen being there and destroying it. There's no chance of bacteria or other kind of biological contamination destroying it. So we can have a really clean insight into the kind of asteroids that were landing on Earth and bringing all these really exciting organic material to Earth that may have formed life. We call these organics the building blocks of life because even though they're quite simple, there are a few amino acids and lipids, so fatty acids that can form cell membranes. When you start putting them into a hot spring pool or putting them into a deep sea vent, they can start coming together in certain ways that look a lot like life. I think as well that asteroids like Bennu would have been landing on Venus for a very long time as well. It would have had this inventory of all these organics being deposited there, which may have simulated some kind of interesting life-like chemistry as well. So when we think about the origin of life on Earth and things like Bennu and what kind of organics were around billions of years ago when these planets were forming and when life was forming, Venus and Mars and all the other planets in our solar system probably had quite similar organics delivered to them as well. So if you think about our place in the solar system, we weren't that different to Venus or Mars. So why is life here? And why may there not be life elsewhere? Is this big mystery we're trying to figure out.
Thank you once again for joining us, Luke. It's been really interesting hearing that, and we'll look forward to seeing you on the show again another time.
Oh, definitely, I'd love to be back. So thank you so much, and thank you to all your listeners. So I'll see you later.
Thanks for listening to the show. You can check out the BrainsMatter website at www.brainsmatter.com, and you can find all the other episodes of the show there. There's also other information on the site, such as guests who've been on the show and subscription details. You can also find BrainsMatter on YouTube, so make sure you like and subscribe if you're a YouTube listener. If you want to support the show, please consider becoming a Patreon at patreon.com/brainsmatter and signing up to one of the options there. Or you can donate either once off or regularly via PayPal. All you need to do is click on one of the PayPal donation options on the right-hand side of the website. If you have any comments or suggestions, you can leave an entry on this episode's show notes on the webpage or on YouTube, or you can send me an email. All my contact information can be found on the BrainsMatter website. The theme music Soul of the Machine was composed and performed by Clive Weeks and is used with his permission. I hope you enjoyed the show. Bye for now.